Welcome you all to the new session of computer graphics. Today we are going to learn about DDA line drawing algorithm. It is also known as digital differential analyzer algorithm. This algorithm is used to plot the pixels of a line. We usually used built-in line functions to draw lines, but instead of using a built-in line functions, we can use this algorithm to identify or to understand how actually every pixel on a line is plotted. Let us move on to the algorithm. DDA line drawing algorithm is capable of drawing lines with slope less than 1, and also this algorithm can draw lines with slope greater than 1. Let us understand what is the difference between these two cases. Consider this line. It is your xy axis. If this is the line, this point is x1, y1 and this point is x2, y2. Then this distance is the distance between two y values, because this is the y value of first point, this is the y value of second point. So distance between two y values can be labeled as delta y. Similarly, this is the x1 and this is the x2. So this distance from here to here, this distance is the distance between two x values and it is labeled as delta x. So the distance between two y values is labeled as delta y and the distance between two x values are labeled as delta x. When we closely observe this figure, we can understand that comparatively delta x is greater than delta y. So we can write the equation of slope m is equal to delta y by delta x. We all know that slope can be calculated using this equation, m is equal to delta y by delta x. Now as we see or as we observed in this figure, delta x is greater than delta y. That means compared to this value, this is more greater. Let us take an example. If this is a situation, delta y is 3 and delta x is 8. I am just giving you an example so that you can understand how delta x is greater than delta y. In such a situation, when you will calculate the value of m, definitely value of m will be less than 1. So what is the rule? Whenever delta x is greater than delta y, the slope will be less than 1. Clear? Move on to the next figure. If this is the line, then this is x1, y1 and this is x2, y2. Then typically this is the y value at this point and this is the y value at this point. So this is the y value and let this be the y value. So the distance between two y values, this can be treated as delta y. Similarly, this is the x1 and this is the x2. So distance between two x values is represented by delta x. When we observe this line, it is clearly understood that delta y is greater than delta x. Again, I am writing the equation for slope m is equal to delta y by delta x, but here delta y is greater than delta x. Taking an example, let it be 8 by 3, where delta y is greater than delta x. In such a situation, when you will calculate the value of m, definitely m will be greater than 1. So you learned two new rules. That is, while drawing lines, you all know that line has two endpoints and you already know how to compute the slope value for a line. The equation to compute the slope is m equals delta y by delta x, and if delta x is greater than delta y, then m will be less than 1, and if delta y is greater than delta x, then m will be greater than 1. So these are the two different situations. Let us now understand how DDA line drawing algorithm solves both these situations and tries to plot the pixels of a line. Let us take the first case where slope m is less than 1. As I have told you, when m is less than 1, delta x is greater than delta y. From this, it is also understood that if delta x is greater than delta y, then x increments faster than y. Clear? What did I say? If delta x is greater than delta y, then x increments faster than y. Clear? Okay, so I can write like this: xk plus 1 is equal to xk plus 1. Now what is this xk plus 1 and xk? Let me explain. Let this be your line. Then this point is x1 y1 and this point is x2 y2. From the starting point to ending point, you have to plot all the pixels in between. For this, you have to compute these xy values that lie between x1 y1 and x2 y2. So, to get the next value of x and next value of y, we have to use the current value of x and y. What did I say? To compute the next value of x and y, we use the current value of x and y because every pixel has its own x and y. Similarly, to compute this point, to compute the x and y of this point, we need the values at this point. Clear? So, by using the values at current position, we can compute the values of next position. And from here, we can compute this value. In this way, from the starting point, slowly, we will compute all the xy positions and finally, we reach at x2, y2. Clear? So, let the current value of x be represented by xk, current value of x, and let the next value of x be represented as xk plus 1. That means value of x at next position. This is value of x at current position. Similarly, value of y at current position be yk and value of y at next position be yk plus 1. Clear? Okay, now I am writing like this. Next value of x can be computed by adding 1 to the current value of x, that is xk plus 1 can be calculated by xk plus 1, that means adding 1 to the current value of x. Clear? So in this way, you can easily obtain next values of x. Clear? So from this, we can say if xk plus 1 is equal to xk plus 1, the difference between two adjacent x values is always 1. Difference between two adjacent x values is always 1. I can rewrite this equation. That is xk plus 1 minus xk equal to 1. Taking this value to the LHS. So now it is clear. Difference between two adjacent x values is 1. From this, I can say therefore delta x is equal to 1. What is delta x? Difference between two x values. So if this is 1, I can say delta x is 1. So taking the rule once again, when delta x is greater than delta y, we are talking about a case with slope m less than 1, and in such a situation we can write, since dx is greater, x value increments faster than y value, therefore we can say next value of x is equal to current value of x plus 1. From this we can say, since the difference between two x values is 1, delta x is 1. Therefore, I am writing m is equal to delta y by delta x. M is the slope. If m is equal to delta y by delta x, what is delta y? Delta y can be written as m into delta x. Cross multiplying these two values. So I can write delta y is equal to m into delta x. Now what is the value of delta x? Delta x is 1. So I can write delta y is equal to m into value of delta x is 1. So m into 1 is m. So I got the value delta y is m. Delta y equal to m means difference between two y values equal to m. That is yk plus 1 minus yk. This is two adjacent values of y, and difference between two adjacent values of y is m because delta y is m. From this I can rewrite it, taking the yk to the right hand side. I can write yk plus 1 is equal to m plus yk. That means next value of y can be computed by adding slope to current value of y. So I got two equations. If we are talking about a line with slope less than 1, then delta x will be greater than delta y. Therefore, x increments faster, and hence xk plus 1 equal to xk plus 1. Also, yk plus 1 is equal to yk plus m. So we got two equations, which clearly states every time to get the next value of x, we have to add 1 to the current value of x, and to get the next value of I, add m, which is the slope, to the current value of y. Clear? Let us move on to the second case. Second case is a line with slope greater than 1. And we already know that all those lines which have slopes greater than 1, therefore dy will be greater than dx. That is, delta y will be greater than delta x. If delta y is greater, it clearly indicates that y increments faster than x. And hence I can write next value of y can be computed by adding 1 to the current value of y. What is it? Next value of y can be computed by adding 1 to the current value of y, which means distance between two adjacent y values is 1, and hence I can write delta y equal to 1. So here x increments faster, so next value of x equal to current value of x plus 1, and using this equation we will be computing delta y value. But here, since delta y is greater, y increments faster, and hence we can say next value of y equal to current value of y plus 1, which means delta y is 1. Now using this value we are going to compute the value of delta x. Let us write the equation m equal to delta y by delta x, where the value of delta y is already known. I can write m equal to delta y by delta x, and from here delta x can be written as, how can delta x be written? Delta x can be written as delta y by m. From this, when you cross multiply, you will get m into delta x is equal to delta y, and then delta x is equal to, again dividing by m, you will get delta y by m. So the equation for delta x is delta y by m. From this equation you will get this. Once this is written, you know that the value of delta y is 1. So you can write it as delta x is equal to 1 by m. If delta x is 1 by m, what does it mean? Distance between two x values is 1 by m. Then I can write xk plus 1 minus xk. xk plus 1 and xk are two adjacent values, and difference between two adjacent values is 1 by m. Rearranging the equation, taking xk to the right hand side, I can write xk plus 1 is equal to xk plus 1 by m, which means next value of x can be computed by adding inverse of the slope to the current value of x. So again I got two equations. Next value of y equals current value of y plus 1, and next value of x is equal to current value of x plus this inverse of the slope. So this is how new points are computed in DDA line drawing algorithm. Clear? So generally we can say if lines are having slope less than 1, next value of x can be computed using current value of x plus 1, and next value of y can be computed using current value of y plus m, which is a slope. Similarly, if we are trying to plot the pixels of the line with slope greater than 1, then next value of x will be current value of x plus inverse of slope, and next value of y will be current value of y plus 1. So using these equations you can simply plot the pixels of a line using the algorithm DDA. Now let us see how DDA line algorithm can be written. We have already understood how it works. It uses two sets of equations. One set of equations to plot the lines with slope less than 1 and another set of equations to plot the lines with slope greater than 1. And using these set of equations, DDA line works in such a way that all the pixels between the two end points are plotted correctly. Let us now see how the algorithm can be written. We know that if this is the line, the starting point is labeled as x1, y1 and the ending point is labeled as x2, y2. Store the values of x1 and y1 in two separate variables x and y. Value of x1 is stored in x and value of y1 is stored in y. After that, you have to compute the values of delta x and delta y. Delta x can be computed by subtracting x2 minus x1 and delta y can be computed by subtracting y2 minus y1. So x2 minus x1 is computed and stored in dx and y2 minus y1 is computed and stored in dy. Simply store the starting point in x and y, then compute delta x and delta y. After computing these two values, we have to identify among these two which one is greater, because if dx is greater then it is case 1, that is slope m is less than 1. But if dy is greater then it is case 2, that is slope m is greater than 1. So we have to identify which of these is greater. Next step, check if dx is greater than dy. If this condition is true, which means dx is greater, in such a situation, store the value of dx in the variable step. But if this condition is false, then it indicates that the greater value is in dy. Then store the value of dy in step. So after completing the execution of step 4, the greater value will be moved to the variable step. If dx is greater, then that will be moved. If dy is greater, then that will be moved. Whichever value is greater, the greater value will be moved to the variable step. Then after that, the next step is to compute the increment value of x and increment value of y. Which means by how much value x should increment and by how much value the y should increment. So we are computing x increment is equal to dx by step, and y increment can be computed using dy by step. This is the division operation. After computing x increment and y increment, you are entering into a loop. This loop will be executed step number of times. Step means either dx or dy. Whichever value is stored in step, that much time this loop will work. That means if it is a line of slope less than 1, then the loop will work dx number of times, and if it is a line of slope greater than 1, then this loop will work dy number of times. Okay, and in each iteration, next values of x and y are computed. How? Next value of x means current value of x plus the x increment, and next value of y means current value of y plus y increment. And once all the values are computed, each time after computing the value, if the value is a floating point value, then you have to use a round function so that the floating point values can be converted back to integer values before plotting. As we all know that it is not possible to plot floating point values on screen because x and y must be integer values. So while calculation, if you get floating point values, so to convert back these floating point values to integer values, use this round function. In this way, every xy value will be computed and will be plotted on the screen. Now let us see how the two cases work in these steps. Let us move on to case 1. Suppose we are having a line with slope less than 1. As per the demonstration, then dx is greater than dy. Since dx is greater, this condition will be evaluated to true and value of dx will be stored in step. So step is now having a value dx. After this, we are going to compute x increment and y increment. So x increment means dx divided by step. That is dx divided by value of step is dx itself. So dx divided by step will be substituted by dx divided by dx itself. So dx by dx is 1, which means x increment is 1. Now let us compute the y increment. Y increment can be computed using dy divided by step. We know that the value of step is dx. So y increment can be computed as y increment is equal to dy divided by the value of step, which is dx. Dy by dx means m. It is the slope. So clearly, if m is less than 1, since the value of step is dx, dx is greater, so dx will be stored in step. X increment will be 1 and y increment will be m. And this loop will be executed dx number of times. Each iteration calculates the next values of x and y. That means next value of x is equal to current value of x plus x increment, which is 1. And next value of y is equal to current value of y plus y increment, which is m. So this is what the equation we have learned. That is in case 1, next value of x is current value of x plus 1 and next value of y is current value of y plus slope. You got the equation. Let us check how the same algorithm works for the slope greater than 1. If slope is greater than 1, then dy will be greater than dx. At that time, value of dy will be stored into the variable dx. Let us compute x increment and y increment. X increment means dx by step. At present, step has the value dy. So x increment will be dx by dy and y increment will be dy by dy. We got x increment is equal to dx by dy and y increment as dy by dy. What is dx by dy? If dy by dx is m, then dx by dy is 1 by m. And y increment is dy by dy, which is 1. So we got x increment as 1 by m and y increment as 1. Now this loop will work step number of times. That means since it is case 2, slope greater than 1, it will work dy number of times. And in each iteration, next value of x can be obtained by current value of x plus x increment and next value of y is current value of y plus y increment. That means next value of x is equal to current value of x plus x increment, which is 1 by m, and next value of y equal to current value of y plus y increment, which is 1. So using just one algorithm, you can implement both the cases, that is case 1 and case 2. So depending on whether dx or dy is greater, correspondingly the value of step will be updated, based on which x increment and y increment will be calculated. Similarly, next values of x and next values of y will be calculated. So in case 1 you will get this equation, but if it is a case 2 you will get this equation. So in this way DDA line drawing algorithm can be implemented to plot the pixels of a line. Thank you.